Hello, Algebra 2s. Hope you're doing well and doing your homework and keeping up with stuff. Here's the key to the review sheet for Unit 5. I went ahead and already did it, and then I'm just going to talk about it. So I'll give you a quick scan of it if you want to just check the work that you've already done. And check your answers with mine. We'll go ahead and move on to page 2. Here we have my answers. And you can freeze the video and check your answers. Here's my answers for numbers 19 through 25. Alright, here's the next part, graphing radical equations, describing transformations, and the last page, 2 more graphs, and then a lot of solving. So what I'm going to do now is I'm going to go back and I'll talk through and explain. If you're satisfied with your answers, you can go ahead and stop watching and move on to your next task. If you're curious about why things are, I'll walk you through and talk about each of my steps. All right, first off, when we look at this first one, I have a fraction exponent. We're going to share this exponent out to both the 16 and the x squared. If you prefer to rewrite it as a radical, you can go ahead and put both of them the 4th root and then simplify. 16, of course, is 2 to the 4th. So 2 comes out, and this x to the 2/4 power is the same as x to the 1/2. All right. This next one, this 4 and this 2 is how I got this 8. Then I have same base, and I'm going to add my exponents. I can only add exponents if I have a common denominator. So I took 3/5 and 1/2, and I made that into 6/10 and then 5/10, and that's where that 11/10 came from. All right, number 3, I have 8 x's up top and 10 x's down bottom. So when we go ahead and we look at those 8 are going to cancel out with 8 of the denominator x's, leaving me with 2. If you prefer to think about this as same base subtract, you can say 8 or x to the 8th minus 10. Subtract those exponents. That's how I get x to the -2. And then that's why, of course, this is down here in the denominator. This negative exponent is going to come up. This z stays and hangs out. He's fine. When these y's come up, of course, I have fractions, so I have common denominator, and I add the numerators only. So 2/3 plus 2/3 gives me 4/3. My x squared and my z are still in my denominator. All right, we'll take a look at number 4. We're going to share this exponent out to each of these factors. -3 times 2 is -6. -3 times 5 is +15. And -3 times 2/3 is going to be -2. Here's my same base add. So when I add those two exponents, that's how I get the 9. And these two q's drop. All right, so when I look at number 5, this subtraction sign changes everything. I go from having a bunch of problems with all factors to now I'm going to have 2 different terms. This is the first one that changes everything. So I have to simplify each term. And if I wind up with the same radicand, I'm allowed to subtract them. So when I take the square root of 32, that's the same as 32 is 2 to the 5th. So when I look at 32, I can break that down into the square root of 32, and 16 comes out. That's 16 times 2. That's how I get 4 roots of 2 here. My 72, I broke that down into 8 and 9. So I have 8 is 4 times 2. And of course, 9 is also a perfect square. So square root of 4 is 2. Square root of 9 is 3. That leaves me with root 2. So I have 4 roots of 2 minus 6 roots of 2. That's how I get negative 2 roots of 2. And here I have same base is 49, subtract. So I ended up with 49 squared minus, now remember I'm subtracting my exponents. When I go ahead and I put this into a common denominator, 2 is the same as 4 halves. So that's how I get 49 to the 1/2 power. That's the same as the square root of 49, which of course is 7. Here I have to remember these negative signs each come out as an I. So I root 3 times 27 is 9 times 3. The 9 is my perfect square. So my 9 comes out as this 3. So I wind up with I times I is negative 1. And then here's my 3. And then root 3 times root 3, of course, this can be simplified as square root of 9, which is 3. So I wind up with negative 3 times 3, which is how I get my negative 9. Okay, so for number 8, 125 to the 2/3 power, we can rewrite this as a radical if that's easier for you. And you know that the cube root of 125 is 5, so then 5 squared is how we got 25. All right, when we look at number 9, this one it can be a little confusing because there's a lot going on here. So the first thing I did was cross off x to the 0 power because anything to the 0 power is 1. Then I shared out this exponent to everything. So then 5 to the negative 2nd power, put this 5 squared down here. So that's where this 5 squared went. This becomes y to the negative 1st power, and he went down into the denominator right away. This 5 stays, this x cubed stays, this y stays. Don't forget about your denominator. This 2 stays, this x to the 1/4 stays. So this 5 cancels off with one of these 5s, which is where this 5 here in this next fraction comes from. This x to the 1/4 power and this x to the 3rd power, I set up a numerator where I have x to the 3rd minus 1/4 because I'm going to do same base subtract. 3 minus 1/4. I change 3 into 12/4. And that's where I get 12/4 minus 1/4 is this 11/4. So this x to the 11/4 is what's left in my numerator. So those are my x's. These two y's cancel out. This 2 here is part of this. And this x's we already dealt with. So that's how I end up with 10 in my denominator. X to the 11/4. And then 10 in my denominator. Okay, we take a look at number 10. The cube root of 81. 81 is 3 to the 4th power. So 3 3's come out as 1 and 1 is left inside. Now I went ahead and wrote this 1 here because then I can see that 3 of these plus 1 of these is equal to 4 of these. My cube root of 64 I know is 4. So if I have 7 3's and they come out in groups of 3, that's going to give me 2 groups of 3 with 1 left over. If I have 12 y's, they come out in 4 groups of 3 with none left over, and then that's why I have my cube root of x all alone. Okay, so this next one, I'm going to go ahead and deal with my coefficients first. Negative 3 times positive 2 is negative 6. Then I'm going to go ahead, because these indexes match to the fourth power, I'm just going to go, or to the fourth root, I'm going to go ahead and put everything under one radical sign. 6 I broke down into 3 times 2. And I moved this 8 up to the front as my 4 times 2. I have these 2 x's plus these 3 x's are going to give me x to the 5th. These 8 y's and this 1 y is going to give me y to the 9th. When I go ahead and I simplify them looking for the fourth root, here I have 4 2's right here. So they come out as 2. That's where I get my negative 12 from. I have 5 x's, 4 of them come out as 1 left inside. 9 y's, 8 of them come out in 2 groups of 4, leaving 1 left inside, and that's why I have my fourth root. My 3 was left inside, my 1x, and my 1y. All right. Number 13, when I went ahead, and because I have a 1/3 power and a cube root, those two things say the same thing. So I put them all under one big cube root symbol, and then I went ahead and I simplified. 40 divided by 5 is 8, and of course the cube root of 8 is 2. Here I have 1x here and 5 in the denominator, so same base subtract leaves me with negative 4 x's, and then this becomes y squared. So you can write this 2 different ways. If I write it as fractional exponents, I can go ahead and rewrite my x to the negative 4/3 power, and then my y, and then of course that negative exponent goes down to the denominator. I'm going to share this exponent out with each of my factors, making this 4 to the negative 3rd power, which makes 1/64th, x to the negative 3rd power, x cubed in the denominator, and then the cube root of y cubed is going to give me y to the negative 1st power. So that's why all of these move to the denominator with 1 holding the spot in the numerator. All right, number 15, I went ahead and I took the cube root of 5/12, which turns out to be 8, cube root of 27, which is 3, and the cube root of x to the 6th, which is x squared. That one's kind of quick and easy. 16, I went ahead and I simplified this fraction, which left me with the square root of a, and then these 4 b's come out as b squared, and I'm left with the square root of 2. So I went ahead and I rationalized it, giving me 2 times b squared in the denominator and the square root of 2a in my numerator. Alright, so for this one, 3 to the negative 2nd power is 9. X to the negative 2nd power is x squared. And y to the negative 2nd power is y squared, all down here in the denominator. So here's my 9, here's my x squared, and here's my y squared. These 3 x's move up to the numerator, and these y's stay put. So my 9 stays, here he is. 2 of x's cancel out with 2 of those, leaving me with 1 in the numerator. And here again I have same base add. So this is y to the 2 plus 1/3 power. 2 is the same as 6 over 3. That's why I get y to the 7/3 power. Square root of 9 is 3. Square root of negative 1 is I. Square root of 25 is 5. Square root of negative 1 is I. That leaves me with the square root of 5 and the square root of 2 that don't simplify. They can be multiplied to 10. I times I is negative 1. 3 times 5 is 15. This one, the sixth root of 64. 64 is the same as 2 to the sixth. So 1, 2 comes out. We have 20 x's. I'm taking them out 6 at a time. 3 groups come out with 2 left over. 12 y's, 2 groups come out evenly. So when I go ahead and I find this one matches perfectly, not a problem. This one over here, my 2 is even. And it's funny how we could have rewritten this one as 2x to the 10 thirds power and y to the second power. It didn't say simplified, it just said equivalent, so we're good. 20, I'm going to go ahead and take the square root of x to the fifth. I'm going to simplify that. 21, cube root, fifth root. There's nothing I can do here. I'm not going to, I can't multiply indexes that don't match. Interesting note here, if this were the same base, you could have multiplied these fractions, but because x and y are different, that's the best you can do with that one. Here I can simplify and call this to the 4/5 power, and that's where this one comes from. Square root, x to the 4th becomes x squared, which is 49. So 64, this whole thing's to the 1/6 power. 64 to the 1/6 power is 2. And then, of course, I can simplify 10/6 to 5/3. 3 groups of x's come out. And I have 6 y's, which means I'm going to have 2 left over. So it doesn't come out evenly, so I can rewrite them as fraction exponents like this. If I have a cube root, it's going to be a snake, this type of graph. Always a domain and a range of all real numbers. My center point starts at 0, 0, and here I recognize I'm moving back 1, 2, 3, 4. I have a stretch of 2, which means instead of going up 1 and 1, I'm now going up 2, twice as tall. For my square root graph, I'm used to it being an eyebrow, starting at 0, 0, and going up with just one part of the graph. This negative means instead it's going to be coming down and reflected over this x-axis. Here is my horizontal shift, 5 to the positive direction, 1, 2, 3, 4, 5, and then 2 up. And I can see my domain and range. Remember, your domain are your x's and your ranges are your y's. So we talked about the transformations of this graph. Here's my compression. This is naturally negative, so I went to the right 1 and I went up 2. Here's my reflection over the x-axis, and I went back 5 and down 3. All right, last page. My center point, instead of being at 0, 0, is to the left 2, so I'm going to make that a plus. Instead of my graph going from negative and increasing, it's decreasing, so that means it's a reflection. And it stays on the x-axis, so there's no vertical shift. For number 31, my center point from 0, 0 looks like it's gone back 1, 2, 3. That's where this plus 3 comes from. And then it's gone down 1, 2, 3, 4. Now you'll notice on my radical, I kind of have a little lip here, and that shows the difference between what is inside of the radical and what is outside. All right, so lots of good solving of equations here. I'm going to take each side and I'm going to square it, and that's going to eliminate my radical signs. I get an easy answer of 15, but when I substitute it back in, I have me taking the square root of a negative, therefore we're going to call that there's no real solution. If you wanted to talk about imaginary numbers, that would be different, but we're going to say no solution. I'm going to divide by 3 first here and isolate my radical, and then I'm going to square both sides. When I square both sides, I get an easy answer that checks when I substitute it back in. Number 34, my first thing I'm going to do is going to be to add this radical and move it over to this side. Therefore, if I have the same radical, I can go ahead and square both sides, leaving me with some easy math to get x is equal to 6. And then, of course, I can check my, we'll draw this in purple, check my solution. When I look at 35, I'm going to go ahead and square both sides. Notice that this is going to require me to FOIL. That's where I get my x squared minus 6x minus 6x, and then plus. It's a quadratic, so I have to set it equal to 0. So I'm going to subtract x from each side. That's how I get my negative 13x's. It factors evenly, which is nice. I can set each one of these factors equal to 0, and I get an answer of 9 and positive 4. Notice when I put each of them back in, 9 works, but 4 does not. That's why this is an extraneous solution. All right, so number 36. I'm going to go ahead and divide by 2 first. I get x to the 2/3 power is 36. You can go ahead and rewrite this as a radical if you want, taking the cube root of x squared. So I went ahead and I raised everything to the 3rd power. Then I had x squared is equal to 36 cubed. I didn't bother simplifying this because I knew I was going to then be taking the square root. Because I took the square root, we need to make sure we remember our plus or minus, and they both check. Number 37, my first step was to go ahead and square both sides, leaving me with a quadratic that I could factor, and this one checks, this one does not, so I end up with x is equal to 5, because negative 2 is an extraneous solution. When I look at 38, add 1 to each side to get 96. Divide by 2, x to the 4th is 48. I took the 4th root of each side, and that would give me plus or minus 4th root of 48. And of course, I can simplify that. So here I have a cube, so I'm going to go ahead and take the cube root of each side. X plus 2 is equal to negative 10. When I solve for x, I get an easy negative 12. X to the 6th, I'm going to go ahead and take the 6th root of each side. And the 6th root of 729 is 3. Because it's an even, I'm going to go ahead and make sure I remember my plus or minus. Because I end up with 2, I need to go ahead and say, okay, x minus 1 can equal to positive 3, and x minus 1 can equal to negative 3. All right, great job today. Keep it up, do your homework. I'll be back and I'll see you next week.